Hi, welcome to TechSpark's Technology Training School. So in this video, let's learn one program in order to calculate HCF and LCM. This comes inside Module 4, Loops Complex Programs, actually part 3. Part 3, While Loop Programs. So this is the third program I have. Yeah, so we have this third program. So program to calculate the LCM and HCF of two given numbers. First of all, what is this LCM, HCF and GCD? LCM is nothing but least common multiple and HCF is nothing but highest common factor. GCD is greatest common divisor. So if the input is 6 and 10, I want you to display the given numbers are 6 and 10. HCF is 2 and least common multiple LCM is 30. So how do we get these numbers? Let's see it. This is a high school mathematics. So highest common factor or GCD, greatest common divisor, both of them mean the same. How do we find the highest common factor? Just display all the factors. Display all the factors of 10. The factors of 10 are 1, 2, 5 and 10. And the factors of 6 or divisors of 6, 1, 2, 3 and 6. So which is the highest common factor in these factors? So 1 is the common factor, 2 is also a common factor, but highest common factor is 2. So 2 can be considered as HCF or GCD. So in order to do this, to get all the factors, store it in an array, get all the factors of 6 is an engineering method. So that is not necessary for you people. I'll teach you a very easy method that is called as Euclid's algorithm. So let's also see what is LCM, least common multiple. So first we need to display the multiples of 10 and 6. The multiples of 10 are 10, 20, 30, 40, 50 and 60. You can keep going ahead, 70, 80, 90, keeps on going. The multiples of 6 is 6, 12, 18, 24, 30 and 36. Which is the least common multiple? We have the common multiple 10 anywhere, no 20 anywhere, no 30. Yes, 30 is the least common multiple. So this is how we find HCF and LCM. So in order to store this in an array and then display the least common multiple is going to be very tough. So what you can do is you can follow the Euclid's algorithm. So what does this Euclid algorithm say? It's very simple. So get these two numbers. So let's say the first number is 10 and the second number is 6. All that you are supposed to do is just find the remainder of these two numbers. The remainder of 10 and 6. 10 modulus of 6. 6 ones are 6. Remainder is 4. And what you are supposed to do, the first step is to find the remainder of the two given numbers, m mod n. And the second step you are supposed to do is, this is tricky. So you are just store the value of n in m. How will you store the value of n in m? All that you have to do is you have to write m equal to n. M equal to n. And this is the second step. The third step is store the value of remainder in n. So how do you do this one? All that you have to do is n equal to rem. So n equal to rem. Now this is the third step. So what is the first step? Remainder is equals to m modulus n. Second step, store the value of n in m. What happens to the old value of m? It gets destroyed. Don't worry about it. Then store the value of rem in n. So, and then again you have to go back to the first step. So what is the first step? 6 modulus 4. 6 modulus of my new m and n. 6 modulus 4, m modulus n. So 6 modulus 4 you will get 2. So what is my second step? Push the value of n in m. Store the value of n in m. So the 4 value gets stored in m. Similarly, rem value should go into n. So what is the statement? N is equals to rem. So what is my So these are the 3 steps. Again you will have to repeat the first step. How long will you keep repeating? As long as n is not equal to 0. The moment n becomes 0, the whatever the value is left out in m will be our HCF. Let's see what it is. So what is my first step? M mod n. What is my m? 4. What is my n? 2. So 4 modulus 2 will give you 0. 2 2s are 4. Remainder is 0. What is my second step? Move the value of n in m. And what is my third step? Move the value of rem in n. So if you notice, our n has become 0. So whenever our n becomes 0, you need to stop, and whatever is the value of m is our HCF. If n equal to 0, then exit the loop, and HCF is the value in m. And this algorithm is called as Euclid's algorithm. Now let's see how to put this into the code. So I've just given one more example, m and n being 10 and 25. The first step is to find the remainder. 10 modulus of 25 will give you 10 itself. My second step is push the value of n in m. So 25 will be pushed to m. Then remainder value, which is 10, will be pushed to n. I get 25 and 10. 25 modulus 10, that is my first step. I'll get remainder as 5. My second step is push the value of n in m. The sequence is important. Second step should be n should be pushed to m. And then third step is push the value of remainder to n. The value of n will become 5. So my first step again is 10 modulus 5, that is 0. My again second step is push the value of n in m. Push the value of rem in n. It becomes 0. So my m is 5 and n is 0. So whatever is left out in m will be the value of HCF. When will you take the value of m as HCF? Only when n becomes 0. So here highest common factor between 10 and 25 is 5. Let's see a flowchart for this and then write the program. So always your flowchart should start. So read P and Q. You take the input as P and Q. Store the value of P and Q in m and n. You need to save it for future use. Whatever changes we will do, we'll do it only to m and n. We will not do it for P and Q. So as long as n is not equal to 0. Remember in the Euclid's algorithm, we checked as soon as n becomes 0, we stopped the loop. So that is the loop check here. As long as n is not equal to 0, my first step is to find the remainder of m and n. So remainder of m and n. So how do you find the remainder of m and n? So rem is equals to m mod n. So what you are supposed to do? Second step is store the value of n in m. And then the third step is store the value of rem in n. So my first step is to find the remainder. Second step is store the value of n in m. The third step is store the value of rem in n. So how long you will keep doing this? You keep repeating this as long as my n is not equal to 0. The moment n becomes 0, you stop the loop, and then whatever is left out in m, it will be your HCF. So because I am not able to write it in the same slide, I put this label A. I'll continue the label in the next slide. So whatever was left out in in m will be my HCF. Now how do you find the LCM? This is also part of the algorithm. What was the original values? P and Q. The original P and Q, product of the original numbers divided by HCF will give me my LCM. So if my original numbers was 6 and 10, so 6 into 10 is 60. 60 divided by HCF. HCF would be calculated here, that is 2. 60 by 2 will give you 30, and 30 is my LCM. I just have to print HCF and LCM in a proper format. So this is my flow chart. You can pause the video now and then copy down the flow chart. So Now we have program to calculate LCM. Now let's write the program. We can write it in C, C++, Java, Python, irrespective of any language. Right now we are choosing Java. So my first step was to find the remainder, m modulus n, store it in remainder. So push the value of n to m and push the remainder value to n. So these are my 3 steps. How long you will keep doing these steps? As long as n is not equal to 0. The moment n becomes 0, what should you do? Whatever is left out in the m, that will be stored in my HCF. Of course, we'll have to write one comment for every loop. Make sure that you keep writing the comments. Now, also you need to store the original values. The original values are in P and Q, which will be accepting it as a parameter. That I store it in m and n. Make sure that you declare all the variables. I need one HCF, one LCM, one remainder, one m and n. So the original values are accepted as parameters P and Q. Those P and Q are stored in m and n. You write a loop in order to find the remainder, and then whatever is left out in m will be stored in HCF. Make sure that this is outside the while loop. Come outside the while loop and then write down this statement. How do you calculate the LCM? Product of the given numbers divided by HCF. This you have seen in the algorithm in the flowchart also. The given numbers are P and Q, HCF is HCF, and LCM is LCM. And that's all. Thank you.